this lesson, we will learn how to find the inverse of a function. Only a special kind of function has an inverse. Only one-to-one functions have inverses. We need our functions to have ordered pairs with different y coordinates. If these functions are to be one-to-one, the y coordinates must all be different. It looks like the first example is not one-to-one, but the second one is. If we are given the graph of a function, we can use the horizontal line test to determine if an inverse exists. With this horizontal line test, you are checking to see if all the y coordinates are different. The test says that if any horizontal line drawn only intersects the graph at one point, the function is one-to-one, and therefore an inverse exists. To determine if the function is one-to-one, we draw horizontal lines on the graph. If any horizontal line drawn only intersects at one point, then the function is one-to-one. The two functions that pass the horizontal line test are c and d. This is an example that should help us with the concept of finding inverses. Let's say you are wrapping a box. Here is the process you may go through in wrapping that box. You would put the box on the wrapping paper and then wrap it. Next, you could be taping that box up, and perhaps your last step is to put a bow on it. The opposite or inverse of wrapping the box would be to first take the bow off, take off the tape, unwrap the box, and then take the box out of the paper. We would be ending up then where we started. Look closely at the steps of the two tasks. What we see is that we end up doing the opposite tasks in the opposite order. Let's apply this to functions. For this particular function, what you are asked to do to x is multiply by 3 and then add 2. The inverse would need to be the opposite operations done in the opposite order. The inverse should be subtracting 2 first and then dividing by 3. This process that we went through in building the inverse can be done for fairly simple functions. We'll look at a formal method that will help us find inverses to those that are more complicated. Before we move on, look at the notation that we use for inverses. We use the same function name as the original function, and then we say, so that we can say we have the inverse, and then we superscript a -1 to say that we've got the inverse to that function. The formal steps are stated here. We first start by replacing f of x with y. F of x means y, and think of f of x as getting in the way of the process. Next, interchange the roles of x and y. In other words, where you see x, put y, and where you see y, put x. Last, solve for y so that you can use the function inverse notation. Let's redo the last example using the formal steps. We start by replacing f of x with y. Next, replace y with x and x with y. At this point, you have the inverse, but we want to be able to use the function inverse notation, and this notation represents y, just as f of x does. Therefore, our last step is to solve for y. Consider the steps in finding the inverse to a one-to-one function. The second step has us interchanging the roles of x and y. In other words, replace x with y and y with x. What you are doing at this point is switching your domain and range. The x's of a function become the y's of its inverse, and vice versa. If we are dealing with a set of ordered pairs, we are to switch the x and y coordinates to find the inverse. We know this function is one-to-one since all the y's are different. So to find the inverse, we simply need to switch the x's and the y's. And we now have the inverse of our function. Let's take a look at the relationship that we will see when a function and its inverse are graphed together on the same graph. Notice how the domain of a function is the range of its inverse, and the range of a function is the domain of its inverse. On this graph, I have the function, its inverse, and the line y equals x graphed. There will always be a mirror image across the line y equals x for a function and its inverse. There are a number of ways to determine if two functions are inverses of one another. We could find the inverse of one and see if it is the other function. Or we could graph both of them on the same graph to see if there's a reflection about the line y equals x. Our last is to compose the two functions to see if the result is x. If two functions are inverses of one another, then one function will undo what the other has done to x. Therefore, if you compose the two and they are inverses of one another, you will end up with what you started with, which is x. Let's go on to compose these two functions. What we find is that the result is not x. Therefore, the two functions are not inverses of one another. Thank you for listening, and hopefully this has been helpful.